In a town in rural Pennsylvania, there lives a cow that has muscles so big, so strong, that he stands out from all the other cows. On his farm, people often visit to see him. They say, "Billy the Belgian Blue is so cool. Who would have thought a cow could have muscles as big as the earth?" But even though Billy attracts crowds, he still has a problem. Even though his big muscles may seem like a benefit, they can actually lead to various health issues like respiratory problems, low heat tolerance, and mobility issues because of muscle imbalance. His big muscles are from a mutation on the myostatin protein that regulates muscle. Because of the deletion mutation, when the DNA was creating the amino acid for myostatin, a nucleotide base was deleted, causing the amino acid to be changed. The myostatin was then never produced properly, resulting in Billy the Belgian Blue to have large muscles.
I hate my big muscles. Although I make people happy because of them, I can't walk properly, breathe properly, and I'm at a higher risk of disease. It really sucks.
Yo, Billy, you look more like a statue than a cow. What are those muscles for if they can't even run around the pasture or pull a cart? You frozen piece of meat. Yeah, why do you even look like that? It's pretty weird, and we all think so.
You know what? You don't know what it's like. It's time you learn why I look like this, and maybe you'll start to understand and accept me and stop blaming me for once.
We don't need to learn anything. We just know you're different in the worst kinds of ways. You muscly loser.
If they don't listen, maybe you will. I was born with double muscle mass. It occurs when there is a genetic mutation for a myostatin protein. You may be wondering what a mutation is exactly. Well, a mutation is a permanent change in the DNA sequence of a cell. A mutation can be beneficial, harmful, or not even impact you. As you can see, I got the short end of the stick as it leads to a reduced bone density, making me very weak because my bones are shorter and skinnier than other cattle. I also have to deal with many respiratory problems because my organs are smaller compared to my other body parts. I am also more prone to adopting risky diseases like kidney stones, lameness, and heat stress. My mutation affects the myostatin protein, which limits muscle growth. Scientists have found when myostatin is blocked or mutated on the MSTN gene, an increase of muscle growth occurs. For me, I was born with the mutation when I was developing my muscles. A deletion mutation was the mutation that made me look like this. A deletion mutation is a type of point mutation where there is a loss of one or more nucleotides from a segment of DNA. In Belgian blues, 11 base pairs are deleted on the MSTN gene, causing a frameshift mutation that removes the portion of the myostatin protein that makes it functional. When this happens, it leads to a dysfunctional myostatin protein that can effectively inhibit muscle growth, causing increased muscle mass in affected animals like me.
Hey, Billy, what are you doing? Who are you talking to?
I'm talking to the audience. They're the only ones who want to learn about my mutation.
You are such a weirdo. A mutant is what you are. Hey guys, Billy is talking to himself like a crazy Belgian Blue.
I guess to fully understand how my mutation caused me to be different, you should understand how transcription and translation works. Transcription and translation are processes that ensure the flow of genetic information with cells that support growth, repair, and various biological functions. Transcription is the first step. Transcription is the process by which the DNA sequence of a gene is converted into RNA. The DNA is first split by helicase, an enzyme, and a DNA template strand is then used by RNA polymerase, another enzyme. RNA polymerase helps RNA nucleotides line up along one strand of the DNA, following the base pairing rules. The RNA polymerase codes for messenger RNA, or mRNA. The single strand of mRNA then peels away from the gene, and the DNA strands rewind. This is when the process of translation occurs. Translation is the process where a ribosome attaches to the mRNA and translates its message into a specific amino acids aided by tRNA. The transfer RNA, or tRNA, brings the mRNA to a ribosome. From there, the anticodons on the tRNA code for an amino acid, 3 base pairs long. It will not start coding until a start codon, which codes to AUG. On the other side of the tRNA, a polypeptide chain is forming with the amino acids attached. The tRNA codes until a stop codon, which codes for UAA, UGA, or UAG.
Attention animals, we have a new member of the family. His name is Bart the Bully Whippet.
Wow, he has giant muscles just like Billy.
It's nice to meet you. Did you know that we have the same mutation?
No, what does that mean?
I'm so glad you asked.